Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is split linked list in parts. In this question, we're given the head of a single linked list and we're also given an integer k. Split the linked list into k consecutive linked list parts. The length of each part should be as equal as possible. No two parts should have a size differencing by more than one. This may lead to some parts being null. The parts should be in the order of occurrence in the input list, and the parts occurring earlier should be always having a greater size than or equal to the parts occurring later. And finally return an array of the k parts. Coming to the function given to us, this is the function name. We're given the head of a linked list and we're also given an integer k. Our output is an array of nodes. So first let's declare our output. And this output size is of k parts. Now we need to know how many nodes are there inside this linked list. For that, I'm going to create a variable called size, which is initially 0. I create a node called current, which will start at the beginning of the linked list, which is equal to head. And now using this current, let's iterate through the linked list. So until the head is not equal to null, we keep moving current. We keep incrementing the size whenever you access a node and keep moving the current forward. So current is equal to current.next. Now we know the size of the linked list. We can divide how many parts are there. So let's create a variable called split size, where you divide the total size by the number of parts, so size by k. Now we check if there are any reminders. So we take a variable remaining parts and take the modulus using the modulus operator. This will give you any reminder of how many nodes are left. And this remaining nodes we have to assign to the beginning parts, because it is mentioned here that the parts occurring earlier should always have a size greater and each part should not differ by more than one size. Now as we use this current variable to count the number of nodes, so it started here and current is now at the end. Now let's bring back current to process and divide the linked list. So current will come back to head. Now our output is of size k. So we use a for loop where I will start from 0 and I is less than k, and each iteration we are filling each part. Now let's create a new node, assign a value to it. I'm naming it new part and put in a dummy value 0. And now let's create another node. I'm going to name it tail and assign this new part to it. Now let's get the actual size of how many nodes are there, and then we check if there are any remaining parts and assign it to the current part. So current size is equal to the split size. We know at least any nodes should be there in the current part. And now we check if there are any remaining parts. So here you see there are 10 nodes, and if you do 10 modulo 3, you get 1 node. So that is why you add that extra node to the beginning part, and the rest of the nodes have 3. So initially everything has 3, 3, 3. But you have one remaining node, you add it to the first part. So you check if num remaining parts is greater than 0. So if num remaining parts is greater than 0, we increment the current size and decrement the remaining parts by 1. We're incrementing the size only once because they said each part should not differ by more than 1. So you don't assign all the remaining parts to this current part. We only assign it once, and if there is one more remaining part, you assign it to the next part. So if remainder was 2, we assign one node here, and the next remaining part we assign to this part. You don't assign the 2 remaining nodes to the first part only. That is why we are doing only once. Now we take a variable, let's name it j, initially it is 0. So this is a pointer. We check this pointer to iterate through how many parts are there in the current part. So until this j is less than the current part size, keep iterating. Now we have our tail. So we assign tail.next to the list nodes value. So current.val. So current we saw it is initially at the head. So there is no node now. So we have to create a node. So new list node, and the value is going to be the current node.val. And we move tail. Tail is equal to tail.next. We move the j pointer. We increment j. So j was initially 0, j is now 1, and we move the current pointer so that we can access the next node inside this head. So current is equal to current.next. And finally, when this while loop ends, inside this result, we have our result, right? So result of I we're going to use this for loop I. So result of I is equal to this new part which we built. In new part only we are storing tail. So whatever tail has, it will be assigned to new part. So new part dot next for the next iteration. And finally, when this for loop ends, you can return the output which is present inside the array of list nodes result. Now let's try to run the code. So we are moving current, right? So we have to check current reaches the end, not head. Now let's try to run the code. The test cases are being accepted. Let's submit the code. And a solution is accepted. So the time complexity of this approach is big O of n because we're iterating through all the nodes present inside the linked list. The space complexity is also big O of n because we're creating new parts and building the output. So both time and space complexity is big O of n, where n is the number of nodes inside this linked list. That's it guys. Thank you for watching and I'll see you in the next video.